So this part right now is the pharmacology and medicinal chemistry of cholinergic antagonists. We are already done in the previous slide with the direct acting cholinomimetic and the indirect acting cholinomimetic, which talks about cholinergic agonism. This time, this segment is for cholinergic antagonist drugs. So, as we have discussed in the previous topic, there are attachments, substitutions of different um, functional groups in different parts of our omnium, ethylene bridge, and acyl that is unfavorable for their cholinomimetic activity. Now, those unfavorable events can be can turn out into favorable ones, and that will make them cholinergic antagonists instead. So this antagonism can become selective to muscarinic receptor, or they can be selective to nicotinic receptor. So for selective muscarinic antagonist, the prototype muscarinic antagonist is our atropine. It is an extract from your Atropa belladonna. So the pharmacophoric structure indicated in represents the wide variety of your muscarinic receptor antagonist. So it has to have amino alcohol esters, ethers, and amino amides. So there is also presence of cyclic or heterocyclic rings at the R1 and R2 positions to increase muscarinic receptor. And R3 should be substituted with hydrogen hydroxide or ethyl. So position X may be an ester or ether, whereas increased substitution of the terminal nitrogen improves receptor affinity such that the quaternary amine is most potent. So, for us to be more specific, you can look for the structure of atropine and refer or look for the following positions that was being mentioned here for your activity in this section. You can look for R1 and R2 and R3 and double check the presence of the cyclic or heterocyclic rings that made it the prototype for muscarinic antagonism. And also, double check if it has ester or ether in the position X. So again, your activity for this section is to examine the atropine structure for the different specifics mentioned here. So your muscarinic receptor, we have three types, your M1, M2, and M3. Now, there are also drugs that even though they are called selective muscarinic antagonists, they have also selectivity according to the different types of muscarinic receptors such as your M1, M2, and M3. So they have different actions in the body. Now, moving forward, in our nicotinic antagonism or yung ating drugs affecting the neuromuscular junction or the nicotinic antagonists, these drugs are divided into non-depolarizing and depolarizing agents. So for non-depolarizing agents or non-depolarizing antagonists, they all have one or two quaternary amines. So, pwedeng meron siyang quaternary amine that is the same with your acetylcholine, or pwede siyang may second quaternary amine. That also mimics your acetylcholine. So, example for non-depolarizing antagonists are isoquinoline, meron tayong tubucurarine and atracurium under it, and we have steroids such as your pancuronium and rucuronium. So, it depends. Your non-depolarizing antagonist depends on whether they activate the ion channel to cause depolarization of the motor end plate or not. So, doon yung kanyang action sa activation of ion channel. Now, on the second type of our nicotinic antagonism, we have the depolarizing blocker or depolarizing antagonist. So, example for this is our succinylcholine. So, it is essentially two acetylcholine molecule attached together at their acyl oxy group doon sa kanyang acetyl group sa kabilang dulo. So, there are two acetylcholine binded together and they can produce depolarizing nicotinic antagonism. So the drug binds to the same site with or acetylcholine and it can cause motor end plate depolarization and some muscle contraction initially. So, in depolarizing antagonism, the inability of the synaptic acetylcholinesterase to metabolize your succinylcholine results in prolonged end plate depolarization and inactivation of your ion channel. So what happens next is the initial depolarization and muscle contraction will be followed by a paralysis, a flaccid paralysis. So, yun yung kanyang action in our body. So, any acetylcholine that binds to the receptor tends to further the depolarization. So, the process will repeat in cycles to promote more paralysis for the patient. So, that would be for our cholinergic antagonism structure activity relationship.